Welcome to the SBGrid YouTube channel. Software tutorials by developers, lectures by structural biologists, unique content brought to you by SBGrid.
Hi, everyone. Thanks for joining today. This is Jason Key at SBGrid in Boston. I'd like to introduce Eugene Krissinel. Eugene is a group leader with CCP4. So he's going to do back-to-back webinars telling us about the CCP4 Cloud in a nutshell. So automatic structure solution. So Eugene, whenever you're ready.
Oh, thank you very much for introduction and good afternoon, everybody. Good evening to myself. I'm in UK. And many thanks, SBGrid, for the invitation to give this webinar. It is a real pleasure to have this opportunity to present the latest development in collaborative computational project number 4 in protein crystallography, also known as CCP4. Today, I'm going indeed to give a brief overview of CCP4 Cloud and its use for automated structure solution. CCP4 Cloud is the new generation front end for CCP4 software suite, which combines new concepts of project development, graphical user interface, and ability to work both as a desktop and as an online and essentially distributed system. When used online, it benefits from access to computational resources, obviously, zero maintenance burden for end users, 24/7 availability, data backup, and interface uniformity across all platforms. And know that CCP4 Cloud can be used for, not just on laptops and PCs, but also on tablets and smartphones. The development has many specific features, such as integrated access to various web resources, project sharing, so it may be viewed like a crystallography Google Docs, if you like. And it comes with a set of documentation materials and tutorials for self-education. Starting from June 2020, CCP4 Cloud is a regular component of CCP4 distribution, and as such, it can be installed in custom locations. In addition, CCP4 by itself runs CCP4 Cloud servers with world public access. Now a few words about technical insight of CCP4 Cloud. Architecturally, CCP4 Cloud represents a 3-layer network of server nodes of 3 types. User nodes on top here, front ends in the middle, and number crunchers here on the bottom. All nodes in this scheme function completely independently of each other and exchange data only with HTTPS protocol. This makes the whole system geographically agnostic and easily scalable. The nodes can be placed on mixed types of hardware and be a mixed set of Linux, Mac OS, and Windows operating systems. A little bit about the nodes themselves. User nodes provide graphical user interface and tools for managing structure solution projects. For example, making, renaming, deleting projects, starting jobs, deleting jobs, viewing results, and similar to that. They are comprised by any common browser and an optional proxy server which runs on client machine. We call it CCP4 Cloud Client. It is needed for seamless binding of graphical applications such as Qt and some others of a similar nature with the rest of CCP4 Cloud. Front-end nodes, they do not run any calculations by themselves, but rather they provide the overall data logistics in the system. They maintain user accounts, project data, and serve this data to user nodes. They also dispatch jobs to number crunchers and collect results back from them. Front ends are also responsible for obtaining data from data producing facilities such as synchrotrons, for example, and relevant web resources such as PDB, IFDB, and similar to that. In most practical cases, CCP4 Cloud instance would include just one front end. However, multiple front ends may be useful, and they may be used in special cases, for example, to cope with high workload, or to categorize users by institution or sensitivity of their data. Number crunchers are the nodes which perform the actual calculations. They receive job data from frontends, and when job's done, they push results back to the sender. The calculations may run on any type of computing backends. Typically, that would be clusters or single machines, could be virtual machine in generic commercial cloud or anything like that. CCP4 Cloud is not a typical type of application which you type on a command prompt and then it runs. Rather, this is a framework, and its configuration is not predefined, strictly speaking. The system can be configured in a number of different ways depending on your local circumstances, using lightweight configuration files, JSON formatted files. The simplest setup here on the left includes one of each node types placed on the same hardware host, for example, on your laptop. And this configuration is included in standard CCP4 distribution, and it works out of the box, essentially as an alternative to a desktop GUI. Exposing the front end here to the internet converts this single host setup into a server setup suitable for use in a medium-sized lab or an institute here in the middle. So after this technical part, let's get a brief tour over CCP4 Cloud from a user perspective. I'm not presenting more now. So it is important to connect to CCP4 Cloud correctly. Standard CCP4 setup includes 3 launchers which relate to CCP4 Cloud, and they will appear on your desktop or somewhere in system menu once CCP4 is installed on your machine. The one with the gear sign here starts a local configurator or maintainer, where you can choose a preferable browser, Opera in my case, or a server URL if you work with several instances, and also manage CCP4 updates here, general CCP4 updates. The launcher with airplane sign here would start CCP4 Cloud on your own machine. That's the single host setup which I described earlier. In this mode, all data and projects are kept on your device, and all calculations are done on your device. No internet connection is necessary in this mode, apart from accessing PDB and some other resources of this nature. The launcher with Wi-Fi sign here in the middle binds your computer with a remote cloud setup, and this is necessary for seamless integration of code and some other graphical programs with the system. You can always connect to CCP4 Cloud via direct URL. For example, this one, https://cloud.ccp4.ac.uk, and it will work like with a normal website, but code and other things like Dials user interface, CCP4MG, IMOS field, and some other programs would not be accessible in this mode. Direct URL connection is the only choice when you work from mobile devices, which cannot have CCP4 installed and cannot run code anyway. So let's assume for today that we connect to CCP4 Cloud via the Wi-Fi launcher as shown here in the slide. Once connected to the cloud, you're presented with the login page where you can also register an account and regain access if password is forgotten. Do not forget to check on the tips on the bottom of the screen. Maybe something useful in there. For example, how to recover from code crashes. If you like, it will appear on one day, this article. So initially, you will see a list of projects once you log into your cloud account. And there is no projects in the list initially, as you would expect. At this point, you can create a new project with the add button or import a previously exported product, project, join a project shared with you by another user, or load a project from the tutorial library. And this is not such a bad point to start with CCP4 Cloud. However, the first thing that you really should do when you log in first time is going to your account settings here and choosing a proper password instead of temporary password given to you at registration. Also, you are advised to authorize yourself with third-party software providers, global phasing in this particular slide, which unlocks their programs for you. CCP4 Cloud can deliver these programs, but not licenses to you. Regarding the global phasing, they give their software to academic users for free through CCP4 Cloud, but you have to get authorization for their internal purposes, whichever. Also, check options in your account and pay attention to the set of icons on top of the screen here. They link to additional information such as your CPU and these quotas and the actual use levels. Of course, it will be 0 in the very beginning. After finishing with these formalities, you are set to work and you can start your first CCP4 Cloud project now. Easy peasy, you just push add button here and you are presented with the set of 3 basic options corresponding to different project templates. Auto start projects here are suitable for novice users, but also in routine cases where structured solution is not expected to be a challenge. These projects unfold completely automatically, and they can bring you to almost a complete structure. You will need to polish the last bits, such as final refinement and fitting cofactors by yourself, obviously, in this case. Standards template, the second choice in this dialog, they give you the same tools as AutoStart template and more on top of those for coping with difficult cases. Standard projects are developed manually, and therefore a good understanding of structured solution process is essential in this case. Hop on template provides a quick start for cases when you wish to, let's say, continue projects from other systems such as CCP4i2, CCP4i1, Phoenix, or global phasing in CCP4 Cloud. Hop-on projects just let you to import data, model, and phases in one go straightforwardly and proceed with model building and refinement straight after the import. So today, we will consider the simplest type of project in CCP4 Cloud, which is the Auto Start, aimed at providing the highest degree of automation that CCP4 can currently offer to you. A few words, if you let me. Automation is a key, obviously, for getting rid of routine and saving human time, but also for mitigating incompetence. And I think this is by far more important aspect of automation. Automation helps with choosing strategy and tactics in structured solution, resolving ambiguity, and it provides inbuilt expertise, which a user may not have. This is natural and nothing to be ashamed of. By analogy, these days, you do not need to be an electronic engineer to operate your laptop. And ideally, you wouldn't have to be a trained crystallographer to solve a structure. But unfortunately, it doesn't work exactly that way. We are working really hard to that end. And yet there is no ultimate automation in protein crystallography. CCP4 Cloud offers automation on 3 levels. First level corresponds to the set of automated pipelines, which combine many CCP4 programs into a coarse-grained functionality. Each such pipeline uses from several to tens of different CCP4 programs, which work in essentially a non-linear way, and they are a great help in solving structures. This picture gives you just the scale of variety among similar automated tools in CCP4, which are available without CCP4 client. It's just a background, which may be very confusing for novices. But in defense of this picture, I should say that it extends the scope of what is possible. Where one pipeline fails, for example, well, this did not solve the structure with molecular replacement. Another one, for example, Mr. Bump, could often get through. And this is a strength and confusion of CCP4. And of course, I do not pretend that all our programs and pipelines are on this slide. It is just an excerpt to impress you with variety and richness of the choice that CCP4 gives to you. We used to say that there are many ways to skin a cat in CCP4. On a second level, CCP4 Cloud offers a suggestive guidance through structured solution projects. What does this mean? When a task is completed, the next step usually depends not only on current results, but also on the prehistory of project development, and in ambiguous cases on personal preferences indeed. Due to the considerable number of possible scenarios, such guidance cannot be fully algorithmized. So it is kind of a problem if you want to help users to navigate in such huge and complex system as CCP4. So instead of just pre-coding something, CCP4 Cloud includes a learning facility with basic inbuilt knowledge base, which can analyze completed structure solution projects and suggest follow-up tasks on that basis. I think this is something new in the area, isn't it? And finally, the third level of automation may be viewed as a combination of two previous levels. When guidance is applied to automatic development of structured solution projects, we call them workflows. It's a buzzword, but let's call them workflows for now. And this approach leaves user with the choice of very few options when they consider AutoStart projects. Workflows for molecular replacement with given or not given structure homolog, and a workflow for experimental phasing here, just those three. The additional two workflows are optimized for special cases when we deal with a perfect structure homolog and just want to fit a ligand in it, and for structure refinement of already phased structure with ligand fitting. So this part, automatic workflows of CCP4 Cloud, is in active development, and the number of workflows is likely to change in future. And if you ask me, I would expect them not to increase, but to decrease, to make the system even more automatic than it is now. Using these automated workflows is supposed to be self-obvious, and therefore I'm going to demonstrate that only on a single example of molecular replacement with simple replacement. So let's have a short movie. And my connection is unstable again. Is it okay now?
Seems okay now.
Okay, good. So this is how it works. We create a project, given it by name ID and more descriptive title, making sure that AutoStart selection is chosen by default, and this project choose the relevant workflow, simple molecular replacement with search model. Done. Then I give it data from either local or cloud storage. Reflection data, unmerged entity in this case. PDB structure as a search model, which we want to build on. Sequence. Not much can be done without sequence. And then if you have a ligand, and this crystal has a ligand, we can specify it with a three-letter code or smile string, like in here. The ligand will be constructed by workflow and run the thing. Data is uploaded, analyzed, and then the project starts to develop completely automatically without me doing anything. This is all completely automatic. It doesn't go that fast. Of course, there's a movie, but you don't have to be connected all the time. You can switch on and off, and nothing happens. So you can see the project branching, where workflow tries alternative programs or performs multiple runs for adjusting calculation parameters. It did that for model building. Then it created a ligand somewhere here, feed the ligand, then feed waters and did a few tries of refinement with suggested parameters to come to something. And in the end of ends, it ran the deposition task, which doesn't deposit structure to the PDB, but instead it prepares MMC files for a deposition. You need just to download them and upload to PDB website if you like it. And also that task obtains the PDB validation report for you to inspect. Well, I think it looked, but if you add the achieved R factors, then you can see that structure is definitely solved, no doubts about this, but it is definitely also not fully refined. The R free 27%, it's a bit too high for crystal perforated. Right, so how this may be improved, how this project may be taken further now. Okay, for answering this question, consider basic concepts behind CCP4 Cloud projects. Projects are represented as trees, which are built on data flows, and this helps understanding the structure solution pathways long time after structure was solved. For example, you solve the structure and write your paper in 2-3 years after that, then in a plain hierarchy of jobs. It is quite hard to recover what was done in a project with 200 jobs. That one's this one is an easy one, but in reality it could be hundreds of jobs. In this tree, if 2 jobs are connected, that it means that data from the upstream job was used on input in the downstream job. Jobs can see data produced by all upstream jobs in the tree in their branch, but not data from other branches than theirs. The project is developed using just 3 basic operations: adding jobs, cloning jobs, and removing jobs from the vertical toolbar in this page. And there are also a few more convenience functions, as you can see here. They're very simple and very basics. All functions from the toolbar are applied to the currently selected job, which is job number 20 in this particular case. It is possible to select several jobs in different branches using this toggle, multiple to single job selection here, and use their combined output data in a new job. And this is a kind of advanced use of CCP4 Cloud next week, perhaps. Let's see now how this works in practice. And obviously, I should say that all examples in this presentation are greatly simplified for demonstration purposes. So, firstly, inspect the PDB validation report here. Click on deposition twice, it opens, and these are 2 files to download if you really want to deposition. But for now, we want to check what PDB validation reports tells to us. So we scroll it down and see we have a problem with R3. Other scores are more or less okay-ish. In general, this report will show you the problematic places in the structure, which can be verified by inspecting the last refined structure, which also shows a problem with R3. This is inbuilt viewer, graphical viewer, which works very fast, faster than COOT. And you can see the ligand was fit pretty much okay, but indeed there are doubtful places which we now want to correct with COOT. So we attach COOT job to the last refinement job. All data is pre-configured, preloaded. You don't have to change anything in most cases. Started, and COOT starts on the local machine now. So read this notice and do just what you would identify the doubtful place here. It's clear what to do it. We probably need a bit of real space refining there. All right, something like that. Drag it. Good, done. All green. Accept the changes now. All right. Then save the structure with default name in default directory as suggested here, and quit COOT. At this point, data gets uploaded to cloud completely automatically. You don't do anything about it. The job is finished. Now you give it a little bit more refinement again because data has changed. The structure has changed. So we refine it with refmark a little bit. Don't see really much, but we changed not much, to be honest. Right, the gauge is still between yellow and green, so more work is required. And you can see that our factors have dropped down just a tiny bit from 2776 to 2742, but our changes were also so tiny. And this shows you the scale of work needs to be done on this result yet to bring our factors to about 20-21%, as it should be for this structure, if our exercise were for real. Another possible course of action, suppose that you start project in auto start mode, run it, but then you want to rerun a particular part of it with modified parameters, because all these jobs were run with some parameters. You were not in control of it. The workflow decided on the parameter, but you can override the automatic choice. For example, many, if not most, problems in crystallography arise from the suboptimal quality of reflection data. And reflection data was merged and scaled here in job number 2 aimless. Suppose I want to rerun this job and all the rest with the updated data set. So I can clone this job number 2, adjust parameters, and run it, making sure it is kept in automatic mode. This is how it is done. Clone. Opens automatically. I want to select batches because I suspect radiation damage in the end of the data set, so to 50 only, and I want to cut resolution to 1.5. It all comes from the inspection of results, which we did not do here. Keep on auto, make sure, and run. That's it. Aimless is rerun. And then the whole project is repeated after aimless. If you work on in another job, it will be rerun from the other job. And of course, it is not as fast. And in the rerun project, the workflow may be different because data changed and branching may also change accordingly. Not really in this case, but in general, it could be. For example, it ran 4 refmark jobs here, and here it was just 3. Right. So what we can see now that indeed our factors have dropped a noticeable bit from 27 R3 to 25 R3, and from 25% R factor to 20%, 21% R factor. So indeed we had a problem with data, and we can now keep on manual refinement and model building with code and refmark, as was shown above here, only started with a better choice, starting from job 44. That, of course, increases your chances to get R factors as low as possible. And in the end of ends, you rerun the deposition task again, prepare MMC files for deposition, and voila, job is done. You go to PDB website and deposit your precious result. Right. Actually, it is a very interesting topic to see how structure can be brought to lowest possible R factors, but it is out of the scope of this webinar. But these questions are covered very exhaustively at CCP4 schools, and you are very welcome to check in one of those. So please just visit CCP4 website to learn when the next CCP4 workshop is coming. Right. So, sorry. I lost a little bit. Yeah, CCP4 Cloud projects can be renamed, exported as a single file, then imported back or shared with other users. Users can work on shared projects simultaneously. They can start, delete, rename, and open jobs and see how each other actions in very much the same way like in a Google Doc. And this is done very easily. For sharing a project, you would need to know only login names of users to put in here with whom you wish to share. And only project owner can share or unshare project. No resharing is possible here. Then once the project is shared, the other user or users receive email notification and can join the project as shown here. Joint projects are prefixed with owner's login name, like here in my personal account, to just indicate what is what more clearly in big list of projects. Right. So this presentation aimed at giving just the basic knowledge of CCP4 Cloud, its operation principles and scope of possibilities. There are many details and features of the interface and of the cloud which we did not cover and could not cover in a short while in this webinar. But it is expected that they can be discovered and learned in course of just working with the system independently. And therefore, I would like to finish this presentation now with some general remarks. CCP4 provides a complete structure solution package, which can be roughly presented in 10 functional categories, as in this slide. CCP4 Cloud delivers on all of them in a set of 68 coarse-grained tasks, which are built on top of more than 200 individual CCP4 components. Altogether, they give a full structure solution line from A to Z with a generous choice of options, which is in best CCP4 traditions. And this makes the development of CCP4 Cloud largely finished by now. Yet it is not completed, and probably it will never be. We still introduce new tasks when necessary, but rather try expanding existing tasks for keeping the system concise and manageable. It is fair to say, I bet, that CCP4 Cloud's functional scope is equivalent to what is given by desktop GUIs like CCP4i2 or CCP4i1 and similar. Yet another point, a good interface should be self-explicable and it shouldn't require much documentation on its own. CCP4 Cloud is actually more about science than program interfaces, and therefore our approach to documentation was very serious. Our documentation is focused on the essence of cloud tasks rather than interface features like buttons and selection boxes and so on. And it includes a set of tutorials and demo projects for self-education and using workshops, schools, and courses. Documentation repository in GitLab is open for all contributors, and everybody is invited to join the documentation project. Here, the possibilities are really endless. For example, if you need CCP4 Cloud for your university courses, you can put up your tutorials on the cloud and use them right from there. Finally, CCP4 Cloud sees quite a reasonable take-up figures. The setup at CCP4 Harwell is open for global public use. It has well over 200 CCP4 Harwell site, or CCP4 Cloud instances, unstable connection, sorry, which are maintained in various locations. They are set up to serve researchers from particular labs, institutions, and industry sites. Right, and the final slide, the project enjoyed enthusiastic contribution from a number of people, really a number of people, and it makes me a real pleasure to express my acknowledgements here. Thank you very much, SBGrid, for inviting me to speak about it. And finally, it wouldn't be possible to create this modern framework without a significant collective effort during several years. Funding from EBSRC and CCP4 is greatly appreciated. That's all. I stop sharing my screen now, and I am open to questions, please.
Oh, that's fantastic. Thank you very much, Eugene. If you have questions, anyone who has questions, you can raise your hand in the reactions button. There's a raise hand, and I can unmute, and people can ask their questions directly. You could also send them by chat to me, and I would pass them on to Eugene. I see some coming in now. I had a couple of my own. I see those pipelines that you've built out there, and having built just some like rudimentary pipelines, that makes it look really easy. Like those pipelines are not always so easy to build, right? So that's a ton of work that's shown in those like It's a
Yeah, but I wanted to make a point that we built an algorithm which makes these workflows on the fly.
yeah.
It is not a pre-coded piece of script.
One question that came in the chat here: how well does it work for RNA? Which I think is a good question.
How long or how well it does work for RNA?
Yeah, let's just say carbohydrates, RNA. Let's
Right.
if I threw
Nucleic acids is a pain, to be honest. It is difficult to solve any structure with nucleic acids. Regarding automatic model builder for nucleic acids, we got only Nautilus from Kevin Cotton in New York, which is like Buccaneer, but only but for nucleic acids, and Model Craft, which will be released next month with CCP4 8.0. It all depends on how good your data is. If you have good data, then it solves. But to my personal impression, when you deal with RNA, the data is not so good. RNA is very flexible, and therefore crystal is not as good normally on average as compared to protein crystals. So it all comes from data. Sorry, it's all that I can say.
Yeah, but so if your data is good, it should work. There's no reason not to expect it to work, just based on
Also, when we build RNA with our tools, sometimes we see that we get too many symmetry transformations. For example, one part of RNA is in this symmetry operation, and another part appears to be in different symmetry operation. So you need to get good and merge them back to have a plausible structure. I don't know why it happens, but it happens sometimes.
I just had some general questions about what are the storage limits? How many jobs can do?
Right. Currently we give 5 GB like Google to users to start with. And this is not because we are Scrooge. It's because many people do account and then don't use it for a long time. Storage is allocated. On request, we are very happy to increase this quota on individual. So,
is there a time quota? Do accounts eventually get sort of removed after a while? Oh, sorry.
No, we do not remove anything. Users are free to export projects and store them on their local machine if they run out of quota, and we refuse to increase it, which never happened so far. So we do not delete anything. We have disk quotas and we have CPU quotas. CPU quotas are for 24-hour use and for 1 month use. And this is also increasable. We are not hungry for resources so far.
Okay. We have a question from Pete. So go ahead, jump in, Pete.
So actually, I have 2 questions, and the first one is kind of a 2-parter. So is it possible for somebody to start a project in CCP4 Cloud and just say, lock me to this version of CCP4 regardless of how long my project takes? And could somebody say, I have a project from a year ago, can I rerun that with the old version because I want to see, I want to change what happened there?
Excellent question, and answers are negative to both. But this is a very good thought which we did not have in mind, because there were no requests. Technically, it should be possible, but it is not done. Sorry.
I figured I would ask because it's a question that people have asked me before about projects where they're doing various things with the data, and they're not 100% sure about how sensitive it is to program versions.
What you should do in such a case, or us should do in such a case, just to have an old CCP4 setup, which will come with own cloud, and then rerun your project in that version of cloud as well. But you will run out of this option fairly quickly, because with advance in operating systems and computing, old CCP4 distributions stop working on new machines. Yeah, this is inevitable.
Yeah. There's
Right, but to a limited time, let's say 3-4 years, we could keep all distributions. We keep all of them, but not installed and provide this function.
yeah. I don't think anybody still has SGIs that they keep around just in case they want to rerun something from those days.
Some people did, actually. I know.
Yeah, I hope they still work.
Right.
I think we just got rid of our last Indigo too. I think just it was just sadly disposed of during the pandemic. So
Terrible.
Yeah. Second question is less structural biology and more web interface related. So could you say anything about how concerned people should be about security, where less so for the version you're hosting, but more somebody has their laptop or their workstation, they're running CCP4 Cloud on there. How concerned do they have to be?
Right. Very good question. Thank you very much. CCP4 Cloud is built using Node.js, which is a standard Google engine for developments of this kind. And it doesn't talk to external internet by itself. It hides behind a layer of industry-approved protocols. For example, you need to run Apache or Tomcat server and redirect to local host to get CCP4 Cloud exposed to the outside. And at this stage, all the usual professional security protocols are engaged, and your organizational IT is in charge for what's going out and what's going in. That's basically all. These days, we acknowledge that the weakest link in all the system is people's personal laptops, rather than clouds and everything. I think it fully applies to this development just as well. I can tell you, previously we thought industry users would never use cloud because they don't like to transmit data. Last years, we are getting regular requests from industry users for doing exactly that. Yeah, so it is much less a concern than 2 years ago or 3 years ago.
Oh, great. Any other questions? You can raise your hand. You can send them by chat. I had a couple more, but I can. What is the overall compute capacity that the sort of cloud resource has? Is it scalable? At some point, right. You said that you're not really bumping up against the overhead. I was just wondering, what does that look like? Like, what's the
right? So it is 2-layer. We have a pool of in-house CPUs at CCP4, which comes to around 200 cores altogether. But this is to cope only with the background workload. In peaks, we offload jobs to STFC Cloud. STFC is Science Technology Facility Council in the UK, which is a big organization. We are part of it, and it runs its own cloud similar to Amazon, OpenStack, and so on. There we can use, I don't know, there was never a limit. We have about 40,000 cores, and just have a very much in-kind allocation from them for peak use, for example, for mass workshops or what. And this is done automatically. The jobs are flowing over automatically to the pool. Okay.
Yeah, as a sort of follow-up question, is there a public dashboard or some facing that people can see, like, oh, what's the load like on CCP4 Cloud right now, or something? Like, if you were curious about, submitting jobs, or it seems like people don't have to wait. Is that?
No. This is not correct. This is not correct. Absolutely, those movies were sped up, of course.
Yeah.
And greatly. The big project which I showed probably took an hour in real time, and most of it was taken by phaser. Surprisingly.
Yeah. Well, I mean, but if it's computing time, that's one thing. If it's queuing time, I think that's the other thing, right?
No, it is computing time.
Yeah,
We don't have real queues so far. We
Okay.
put everything through queuing systems, but we don't have wait so far, wait time. And if you are going for speedy jobs, then cloud may be not the perfect place. Why? Because we are very conservative on parallelization. It's a shared resource. And if you want to serve 100 users with a development which can do 200 jobs in parallel, we limit that development to few jobs in parallel because it's more optimal for sharing resources. Yeah. But then you can do it from your tablet this evening and check results next morning.
Yeah, and that's a good lead into my final question is, can you launch multiple jobs at one time?
Of course.
Yeah.
Of
So
course.
you
can work with several projects at the same time. In your account, you can have several accounts. We don't limit that. Absolutely not. Several jobs in the same project. They are all non-interfering with each other.
Yeah, great. So you
By
could
design.
you could be working on several projects in different tabs or something.
Yeah. By design. By design.
No, that's really powerful. If you're working at scale, if you're trying to, working.
That's the whole point, to scale it up. Yes.
Right. All right. Well, great. Well, I think we can leave it at that. Thank you very much, Eugene. I can't wait to hear about the next week. Eugene's going to give us part 2, which is a sort of advanced interactive molecular replacement, EPM model building. So, well, we'll see you next week.
See you then. Cheers, everybody.
Bye.
Bye-bye.